Hey class, this one goes with 11.1b. I know the first video for this unit got a little long with all that review, but this one should be much shorter, so it should kind of even it out. Today we're going to look at special right triangles. We're going to look at two special right triangles, the 45-45-90 triangle theorem and the 30-60-90 triangle theorem. Hopefully this is something that you'll remember from geometry a little bit as well. So first, in the 45-45-90 triangle, what I want you to remember is that the legs are congruent. So that is the two legs are the same. And then also that the hypotenuse is the leg times the square root of 2. So it's the square root of 2 times as big as the leg. Okay? And then in a 30-60-90 triangle, you have what is a short leg, a long leg, and the hypotenuse. The short leg is always across from the 30-degree angle. The long leg is always across from 60 degrees, and you know that the hypotenuse is always across from the 90-degree angle. And then the two things you'll need to remember for the 30-60-90 triangle is that the hypotenuse is twice the measure of the short leg, so 2 times the short leg. And the long leg is the short leg times the square root of 3. So you'll see we can use the ratios. X square roots of 2. And then for 30, it's x. The 90 degrees is twice the x. And the 60 degrees is the square root of 3 times the short leg, so square root of 3x. Those are the ratios for the two triangles. So let's do a couple examples using those ratios. So find the missing sides. So the first triangle I have here is a 45-45-90. And so that tells me that the side lengths are the same. So if the sides are the same, and then the hypotenuse is the leg times the square root of 2, which means that this side is also 5, and then this side would be 5 square roots of 2. The legs are congruent, and then the hypotenuse is equal to the leg times the square root of 2, so 5 square roots of 2.
Mommy,
yes, honey?
I found a magic rock.
Oh, awesome.
It's really magic.
It's really magic
not
rock?
a normal rock. It's a magic one.
Very cool. Mommy's recording her video, okay? Sorry about that. She found a magic rock. All right. So the next triangle we have is a 30-60-90 triangle. So this is my short leg over here. It's across from the 30 degrees. This would be my long leg, and then I'm given the hypotenuse. So since I'm given the hypotenuse, I'm going to start with the fact that the hypotenuse equals the short leg times 2, which means that 12 equals the short leg times 2. So divide by 2, and the short leg will equal 6. Now you could have signed like x equals 6 or something as a variable there, but the short leg equals 6. Then, since you know what the short leg equals, then you can do the long leg, because the long leg is equal to the short leg times the square root of 3. So the long leg is equal to 6 times the square root of 3. So 6 square roots of 3 for that side. So we have 6 square roots of 3, and 12. All right, let's do a couple more special right triangles. So in a 45-45-90, the legs are congruent. So across from a 45 is a leg. Across from this angle would be the same. So this is 9 square roots of 2. Then I know that the hypotenuse is equal to the leg times the square root of 2. That comes up from my formula. Hypotenuse equals leg times the square root of 2. I don't know what my hypotenuse is, but I do know that my leg is 9 square roots of 2 times another square root of 2. So that means that my hypotenuse will be 9, because it's 9 times 1 is 9, and then the square root of 2 times the square root of 2 will be square root of 4. Well, the square root of 4 is actually just 2, so 9 times 2 is 18. So this hypotenuse is 18 there. So you'll have to plug in what you know and solve for what you don't using your algebra skills. All right, 30, 60, 90 triangle. So across from the 30 degrees is my short leg. Across from the 60 degrees is my long leg. And then this is my hypotenuse. I know that my hypotenuse is equal to 2 times my short leg. So I could say 8 is equal to 2 times x in this case. So divide both sides by 2 and I'd get x equals 4. So the hypotenuse is 2 times the short leg. Then the long leg is the short leg times the square root of 3. So then I know that the long leg is the short leg times the square root of 3. So y is equal to the short leg of 4 times the square root of 3. So 4 square roots of 3 for that one. And that's how we use those special ratios to help us find the trig lengths of the special right triangles. All right, we'll do this one more here. So find missing lengths. If I know that measure of angle A is 30 and we have a 90 degree, then this one has to be 60 degrees. Then I have, this would be my short leg, this would be my long leg, and this would be my hypotenuse. So I know that my hypotenuse is equal to 2 times my short leg, but I don't know the hypotenuse or the short leg. So I'll have to use the long leg first. I know that my long leg is equal to the short leg times the square root of 3. So my long leg is 7 is equal to the short leg A times the square root of 3. So to solve for A, I'm going to have to divide both sides by the square root of 3. So then I'm going to get A is equal to 7 over the square root of 3. Now I can't leave it like that since I have a square root in the denominator. So rationalizing that, I'm going to get 7 square roots of 3 over 3. So that's going to be my A value. So now that I know that that's my short leg, I know that the hypotenuse, or my variable C in this case, is equal to 2 times A. So C would equal 2 times 7 square roots of 3 over 3, which is going to be 2 over 1 times that. So it's going to be 14 square roots of 3 on top, and then 1 times 3 is 3 on bottom. So 14 square roots of 3 over 3. All right. I think that's it for that one. So definitely much shorter special right triangles. Try to memorize these original formulas so you know them. It's going to be really helpful, especially if you go on to take trig next year. All right, thanks for watching.